Peter Donaldson started out as an art teacher at Islander Middle School, tinkering with new models for performance assessment and teaching us storytelling. Peter's ancestral relationship with salmon and his watersheds runs deep. His grandfather, Lauren Donaldson, professor emeritus of fisheries at the University of Washington, was world-renowned as a salmon expert. His father, Jack Donaldson, was director of the Oregon Department of Fish and Wildlife. He is the director of Sustainability Ambassadors, a program coaching student leaders, teacher leaders, and community leaders to drive collective impact at the intersection between sustainability education and measurable improvements in sustainable community conditions. In 2008, he was appointed Distinguished Scholar to the Dan Evans Chair for the Liberal Arts at the Evergreen State College, and in 2010, he was recognized as the Non-Formal Environmental Educator of the Year by the Environmental Education Association of Washington. Today we have met with him to ask him some questions about water pollution in Washington State and Puget Sound. Okay, so to start off, what are the main causes of water pollution in Puget Sound and other bodies of water in Washington?
The main causes of pollution in Puget Sound are surprising. The biggest source of pollution in Puget Sound is you, and you, and you, and me, and all citizens who do little tiny things, and it adds up. So it's called non-point pollution, so you can't point at it. Back in the day, it was called point source pollution. That's the pipe. It goes to that factory, comes out, that's it, that's the pollution. Let's fix that. And we kind of did. Non-point pollution means it's coming from millions of directions, flowing off the streets and the parking lots, into the streams and the ditches, and out into Puget Sound. And there's a lot of different sources.
So our next question is, who or what is being affected by water pollution, such as animals, plants, people, and how?
Who's being affected by water pollution? You think about the sensitivity of the ecosystem. When small amounts of pollution go into the water body, they can be ingested by creatures swimming in the water body. So if a big orca ingests a little bit of toxics coming off of our streets and parking lots, or backing up maybe even from the sewer system. Orca's really big, takes in a little bit of toxic, not a huge problem. You have to reverse that thinking, because if the small microorganisms take in a little bit of toxins, it's a big deal, because they're small. Worse, the feeder fish that are about as big as my fingers swimming in schools, like Pacific herring, they eat quite a bit of the smaller organisms that each have eaten one bit of toxin. So now that feeder fish, that one feeder fish, like a herring or a smelt or a sandalfish, they have like 10 times as much pollution just in the one fish. And a salmon comes along, a teenage salmon trying to work its way up the near shore before it goes out to the Pacific Ocean, and it eats 100 of those feeder fish. Now the salmon has thousands of times the pollution in it. And then a seal eats 100 salmon. And then an orca eats the seals and the salmon. So it's called bioaccumulation. It's accumulating in the biomass from the smallest plankton all the way up. There's also plastic. Plastic does not biodegrade. It solar degrades. So solar degrades means the sun will bake down on that plastic bag or that water bottle that someone did not recycle correctly. And over months, years, it will break down only to, it's kind of crusty. You've seen old plastic, it's kind of brittle and crusty. It breaks down, but it doesn't biodegrade, it doesn't turn back into nutrients for some kind of living system. So it's piling up in different ways.
I read something that mentioned that and how they were finding chemicals and toxins that they don't even use anymore deep down in the sediment. My next question is kind of related to that. But what are the main techniques and technology used? Like, what are the most important pieces?
In wastewater treatment?
Yeah.
This is mostly like a water that's already been polluted, trying to
trying to get rid of it, like clean up the water and filter it.
A couple things come to mind. One is the King County wastewater treatment systems are state of the art. They're the best in the world. People come from around the world to visit what we're doing, so they're really clean. You flush your toilet, and 12 hours later that water's in Puget Sound.
Okay, so my last question, it's not what you were just talking about, but what are your methods for preventing stormwater, also known as runoff pollution, as it's one of the leading causes of water pollution?
So that's good. That's a good question. It's a nice sequence of questions too. We're talking about solutions for stormwater pollution. Nice title. Some solutions. One, rain garden. Disconnect your downspout or put it right next to a sloped parking lot. And a rain garden is just some beautiful organic soil and a little bit of a depression so the water can pond in there. And then the right kind of plants that are native and never need watering. They're used to this. And then the root system attracts the right microorganisms that can literally break down or bind up anything that runs off that roof or the parking lot. So rain garden or a bioretention facility, BioLife retention, retain that stormwater, hold it on site. Bio use life, natural plants and microorganisms to break it down. That's one. Another one is a green roof. So some houses and buildings now are being built with partial green roofs, and those plants can absorb the rainwater and hold it in a big storm event. Third solution, cisterns. You've heard of rain barrels? They're like 50 gallons, about this big, and you can put that by your downspout, and that will slow down the rain a little bit, and you can let it trickle out right into your yard or into a garden. But it's also true that they fill up really quickly. When you get an hour and a half of a big storm event, it fills up. So, and it doesn't last very long into the summer if you're trying to, water your garden with it. But there's, it's very cool because cisterns are starting to become popular in how we design huge buildings. There's a middle school in Snohomish County that just got built. We went up and visited it. It has 1,000 gallon cisterns at every single downspout, 32 of them all around the building. The building's a 2-story building. That may happen when we remodel the schools here on Mercer Island. But picture that. So they not only catch all the rainwater from the rooftop and slow it down and hold it, 32 1,000 gallon cisterns, but they plumb those back into the system and they flush all their toilets with it all year round. So now you're not using any water that people should be drinking, and it costs money to keep that water clean for us to drink. Why would you use clean drinking water to flush the toilet? It's a very modern idea. It's going to happen more and more often. Probably by the time you guys are owning houses, there'll be some kind of a rain catchment system. So it's efficient, and it also slows down stormwater and reuses it. Another solution is pavers. Those are bricks that have spaces between them. Best in a driveway or parking lot strip, because when cars come in to park, they're warmed up, and it's that first half hour where they tend, if they're dripping any oil at all, should get it fixed, but if they are, it drips there. If it's a piece of cement, then it drips there and stays there till the next rain, then it rushes off in concentrated form. But if you have pavers, then the oil can drip through and go down into the soil and then be broken down because it's just a hydrocarbon. There's also a new invention which is in here called pervious pavement, which looks like concrete, but more like a rice cracker concrete, kind of texture, and you can pour water right through it.
Yeah, I saw a video about that on your website.
Yep, it's a new mix.
Was it like the porous concrete?
Porous concrete, right. And then 2 more really, really obvious ones. If you get Cedar Grove compost, which is, if you do food scrap composting in your cafeteria, so that goes to Cedar Grove compost. If you buy that back and put it on your lawn once a year, about now, in fact, in the spring, spread it out, rake it in. Your lawn looks kind of like dirty for a couple of days, but then it soaks in, and that helps increase the sponginess and the health of your lawn. So now your lawn can hold more, and your gardens can hold more. And then you don't need the other kind of strong fertilizers and chemicals because those will wash off. Usually people put too much of those on, and those wash off and cause problems in the ecosystem. And then tree planting. Mercer Island has a tree planting campaign. Seattle has a tree planting campaign. Because if you plant just a couple of trees, that'll be the same as putting in a rain garden. Trees slow the water down, and they hold it, and they put it into their roots. And so that's 5 or 6 solutions. Don't you want to live in an environment, at least your children or your children's children, don't you expect that they would be able to go down to a lake and drink the water?
Yeah.
Or swim in a stream and expect it, go hiking in the woods and drink? I used to do that as a kid, right? You just drink in the stream. But it's not recommended because there's so many people and we have so many materials that have some chemicals in them. We're not quite sure what's the properties or the long-term effects.
Okay, so you've given us a lot of examples already, but what can citizens in our community do to help prevent water pollution and polluted runoff? But since you've given us a lot of examples, like for example rain gardens and cisterns and stuff, what kind of little things can they do without like putting like a lot of effort in or having to
just like around like little household things and just little changes that they can do.
Yeah, here's what comes to mind. It seems small, but it's really important, is dog poop. Scoop it. Because if it's set there on the edge of your grass or in the parking lot or on the sidewalk and someone's not scooping it up, it adds up. It flushes off. It has a lot of fecal coliform bacteria, which can carry other pathogens or diseases. And it gets into the water system and kind of concentrates, and it's a big problem. There's 125,000 dogs in Seattle. And that's 15,000 pounds of poop per year. And if some percentage of that's not scooped, so there's actual projects that the city would probably like your help on, is to put up those posts that have the doggy bags right on them and a little tiny garbage sack. Have you seen those? We probably need more of those in our parks, so it's really easy for people to scoop the poop and throw it away. That's one. Another one is, it's called natural yard care, where you want to educate your parents and other community members through your research and your reporting on if everyone used less of the weed and feed and the intensive chemicals that maybe solve some problems, like get rid of some weeds and some bugs, but they basically kill everything, and it's hard on the environment. Stop using those and start using natural yard care. It's really simple to shift over. You're a gardener in both situations, but you can let go of the toxic chemicals that run off with stormwater. Never flush any pharmaceuticals. Like, oh, we got some extra prescription drugs in the cabinet. We need to get rid of these. I certainly don't want my young kid thinking they're candy and eating some of these. I should get rid of them. Where should they go? Oh, just put them down the toilet. It's a horrible idea, because the wastewater treatments can't clean up those and they get into the system. These are all little things that if you start advertising could happen. Car washes, really important not to wash your car on the driveway, because that soap is not good in the environment. And what you're getting off your car with the soap is the engine grime and grease and the pollution kicked up from the roadside. And that goes down. So it's best to take it to a commercial car wash, because they treat it like toxic waste and take it to a toxic waste treatment center. You know, one other is household products. You might look at 7th generation products. It's mostly my soaps, my cleaning soaps, my laundry soap, my toilet paper, my paper towel, my paper napkins, all come from 7th generation. And so if people began to research what are the companies that you want to give your business to, you have to figure out that, because they don't use toxics, or at least things that aren't bad for the environment. Then you can start buying those, and even at your age you can vote with your wallet. You can't vote actually till you're 18, but by buying those products, not those products, based on your research, you could start a movement. So now we have 5 or 6 everyday things that people could begin to think about.
So I have another question. So is in the Puget Sound mainly, but also just in and around the Puget Sound, are we pretty bad off with our water pollution, or if you have to compare it to other states, are they doing better than us? Or?
That's a really good question, and the big comparison usually is Chesapeake Bay, which is in Washington D.C. area, and it's had human civilization for about 200 years longer than we have. 150 years ago, the native treaty negotiations, that's because white settlers were just coming in. But on the East Coast, you can go back to Jamestown, 1609, there's been hundreds of years of human impact on the environment. a lot of that around that beautiful bay, Chesapeake Bay, which is a big saltwater bay, like sound like ours.
Yeah.
So they're similar. And it is really in trouble, and it's really much harder to clean it up at this stage. So we're in a much better position in the Chesapeake Bay, and yet the warning signs are up. If we don't figure it out now, it will go in the direction of Chesapeake Bay. And there's a bunch of government agencies, nonprofits just like mine, who are working in Chesapeake Bay to try and bring it back, but it's harder. So that's kind of an interesting comparison.